All right, this is just kind of a preparatory question. What two polynomials could you multiply to get 2x squared minus 6x? Remember your polynomial multiplication. Well, they're both divisible by 2, right? So you could say it's 2 times x squared minus 3x. Do a quick double check in your head. 2 times x squared, yep, that's 2x squared. 2 times negative 3x, yep, that's negative 6x. That works. Is there any other answer? Well, they both had a 2 in them. They also both had an x in them. So what if we wrote it as 2x times something? Well, if we did 2x times x, that gives me the 2x squared. And 2x times negative 3 would give me the negative 6x. So that's all we're doing. Factoring is just multiplication backwards. An answer to what we would have done in chapter 5 is a question in what we're doing in chapter 6. So we will do two sections in this lecture, 6.1, which is factoring and finding the greatest common factor, and then we'll do grouping as well. So first of all, let's just remember factoring with numbers. If we had 420, well, we know 10 goes into it, so we could say that's 42 times 10. Now 42 isn't prime. 42 is 2 times 21, or 6 times 7. It doesn't matter which way you do it. 10 is 2 times 5. Now 2 is prime, but 21 isn't. It's 3 times 7. So I could write my factorization of 420 in just a minute. With 110, it's 11 times 10. 10 is 2 times 5. So my factorization of 420, I'm just going to put them in order. 2 times 2 times 3 times 5 times 7. And my factorization of 110 is 2 times 5 times 7. That's essentially all we're doing, but we're going to do it with polynomials. We want to break them into little pieces, and when I multiply the pieces together, using FOIL or whatever, I'd get the big polynomial. Now before we go on to polynomials, though, we need to talk about the greatest common factor. So let's look at these two numbers again, 420 and 110. I'm going to have these orange lines come up on the next slide. So there's my factorization of 420, and there's my factorization of 110. Do you remember what the greatest common factor is? Not what it is in this example, but what it is in general? Good. It's the biggest number that goes into a set of numbers. It's the largest number that they each contain. So what is the greatest common factor of 420 and 110? You might be able to just see it, but in some numbers you actually need to go through and look at the factorization. So let's look at this one. Well, 420 and 110, they each have 1, 2 as a factor and 1, 5 as a factor. So the greatest common factor is 2 times 5, which is 10. That's the biggest number that will go into 420 and 110. That will be our first step for factoring with polynomials. So let's look at these two different examples. The blue line separates my examples apart. So first of all, 8x squared y, 6xy cubed, and 4x. I want to kind of break these into pieces. Breaking these into pieces is not necessary, but I think it's helpful at least at the beginning. So 8, what is 8 equal to? 8 is 2 times 2 times 2. 6 is 2 times 3, and 4 is 2 times 2. I've also written the variables out. Again, you don't need to write it this way. I'm just doing it to try to help illustrate what's going on. So what is the biggest thing that they each contain? Let's start by looking at the numbers. The first term has 3 2's. The next one has a 2 and a 3, and the third has 2 2's. So I could say they all have at least a 2. Good. Now talk to me about x's. The first one has 2 x's, the next one has 1, and the third one has 1. So they each have at least an x. Now what about y's? Well, the first two have y's, but the third one doesn't. So y is not part of the greatest common factor. The greatest common factor for those first three terms is just 2x. Okay, for the next one. Again, you don't need to write it as pieces, but I'm going to so we can get used to it. 9 is 3 times 3. 6 is 2 times 3. 12 is 2 times 2 times 3. And if I wrote out x and then y plus 1, and however many x's there are, however many y plus 1's there are. Let's go through and look for the greatest common factor again. Looking at the numbers, they each have a 3. Good. A couple of them have a 2, but not all of them have a 2. Everybody has to have it for it to be in the greatest common factor. They all have at least how many x's? Good. They all have at least 1x. Now they all have how many y plus 1's? The first one has 2, the second one has 4, the third one has 3. So they all have at least 2 y plus 1's. And that is how we find the greatest common factor with polynomials. I will give you some examples to work on your own in just a minute.